Well, hello, geometers and general seekers of truth. In this video, we will solve a problem very similar to the previous one, except just like what we've been doing, we want to solve a problem without the numbers so that we can work with variables. And by doing that, we make the problem more general. We make the solution more general. The solution becomes more powerful, and it applies in more cases than just a single problem. So let's set this up here. Given in the figure below, the measure of Jm is equal to x degrees, and the measure of LK is equal to y degrees. Find an expression in terms of x and y for the measure of angle 1. So like before, what we're going to do is start out by making some inscribed angles. So that's a very big part of this lesson. So I'm going to start this time by taking the measure, let's see, a line and connecting it from J to L. And by doing so, what I end up with here is, what I end up with here is this angle that intercepts this arc right there. Okay, so we can say that angle L intercepts arc JM. And we can extend on that and say that the measure of angle L must be equal to 1/2 of the arc of JM, which is x degrees. So this is x, okay? And this again is the inscribed angles theorem. Okay, step 2. Now, hopefully what we can see here is that by drawing this line from J to L, we not only have one inscribed angle, we are able to produce a second inscribed angle here. LJK, or angle J up here, intercepts this arc. Okay? So we can say that the measure of angle J is equal to 1/2 of y. And really, for the exact same reason, that is also the inscribed angle. And now, just as we did before, if we take a look at this triangle JLN, and angle 1, we can come to our final answer. So let me try to replicate this a little bit here. Should look something like that. So this point here is J, this point here is L, and this point here is N, and we have angle 1 right there. And let me label this stuff too. So remember that angle J here is 1/2 x, and angle L here, whoops, I got that backwards. Angle J here is 1/2 y, and angle L here is 1/2 x. So in my final couple of steps here, we can say that the measure of angle J plus the measure of angle L is equal to the measure of angle 1. And this comes from the exterior angle theorem. It's the exterior angle theorem. And then finally, we can just rearrange stuff a little bit. Not rearrange, excuse me. We can just make substitutions. So measure of angle J is 1/2 y plus the measure of angle, excuse me, I keep getting this mixed up. L here is 1/2 x, not 1/2 y. So L here is 1/2 x. Okay. So back to this. Measure of angle J plus the measure of angle L, which is 1/2 x, must be equal to the measure of angle 1. And so this formula here gives us a, a way to quickly solve this problem and the problem in the previous video, and all problems like that that has the same type of format, the same type of picture, by applying what we know about these arcs. So if if we know what x and y are, we know the numbers for x and y, we can make the substitution and solve the problems relatively quickly. So as always, and also this is a theorem, and what we've done here is a proof of that theorem. We can name this. You can name this whatever you want. Ask your teacher how to name this theorem so that it makes sense. Textbooks usually name it like based on the chapter, like theorem 10.2 or theorem 11.5 or whatever. So I leave it to every class and every teacher to name this theorem. But this is a theorem. It says something specific about about this angle here that's sort of in the middle in some random spot inside of the circle. As always, keep working hard. Ask for help when you need it. Thank you for watching and have a wonderful